Unconscious biases exist in our data. They exist in two forms. First, there are the human biases that exist in data because data found in the world has existing biases with regard to properties like gender, race, and sexual orientation. We can think of those biases in terms of the way that they manifest in our data samples. There may be reporting bias by our subjects because they only choose to reveal certain aspects about themselves or their opinions. There may be selection bias, that is, only those subjects that get into our samples, those subjects represent a privileged type of user. Let's say we are developing a machine learning model to find fraudulent transactions. Can you see what kinds of problems we might have? Suppose we train the model on historical transactions. What could go wrong there? Well, we may have a reporting bias if our customers tend to use cash in grocery stores. We only know about the places where they tend to shop with the card, and we might wrongly assume that all grocery store transactions are fraudulent. Just because we haven't seen enough grocery store transactions that use a card because all of our customers use cash. However, many US states issue state benefits in the form of debit cards. And this will have the impact of denying poor users the ability to use those cards for food. This is an example of reporting bias that causes a real-world outcome. Or maybe our cards get used only at large department stores. Our model might start to reject transactions at smaller stores because there aren't enough of those. That's an example of selection bias from the perspective of the small business owner who doesn't get any business from the credit cards that we're issuing. Second, we can also run into human biases that arise as part of our data collection and labeling procedures. Confirmation bias refers to only looking for data which confirms our hypothesis. And automation bias refers to the biases which crop up when the data we use is just the data that is easily automatable, the data that we can quickly get. For example, suppose we are building a product recommendation system. We believe that someone who buys a tie will look for men's shirts. So we might restrict our data collection to only men's apparel items. But women do wear ties. So this is an example of confirmation bias. Automation bias is surprisingly common. If men's apparel and women's apparel are run by different parts of our organization, it is quite possible that this is why we might have collected only men's shirt sales. The presence of a silo has caused unconscious bias. You might also have automation bias if you have a fancy digital data collection system at some locations, but other locations are still sending you faxes. Chances are that you'll prioritize the data that's easy to collect. So what's the impact of biases in collecting data and labeling data? It affects the entire pipeline. In machine learning, we begin with our data. So the biases in the original data are going to get reflected downstream in our models, and consequently, they're going to result in biased outcomes. The result is that biases can appear at every point of the data pipeline. It appears at the point of collection. What kinds of data are accessible? Does the availability of data privilege a particular group of people? Does it put another group of it at a disadvantage? What transformations are you making to your data? And do these transformations exclude one group compared to another? It can also appear in the process of labeling. What human biases are your human annotators introducing into the data? How stable are your categories of classification. It can occur at the model level. Does a particular objective put certain subgroups of people at a disadvantage compared to the group in aggregate? And those biases will appear downstream in the output of our model, and our users will see an effect or outcome as a result. The challenge that we run into when creating a system that is fair and inclusive to all is that machine learning models learn from existing data collected from the real world. So an accurate model might learn, amplify problematic biases that exist in the data based on race, gender, religion, and other characteristics.